Sorry about that. 30 seconds late here. Anyway, today, let me go ahead and get rid of this. We'll talk about that on Thursday. Anyway, today we're doing just a very, very brief tutorial on graphical user interface and event-based programming. And this is something that's at the end cap, of course. It's unfortunate, but it's a reality that when people think about programming, when they think about computers, they only really think about the consumer end, the graphical user interface end. So when somebody thinks computer science or you're programming, they think you're putting together these GUIs all day. And it's actually a very, very small part of programming. The vast majority of software is actually software that is glue code. It makes one system speak to another system. And the whole point of programming and the whole point of making programs is to automate things. A graphical user interface program does not do that. All right? It's still a human user sitting at the keyboard or sitting out with their mouse now with a graphical user interface and doing things. But it does require a little bit of different thought process because up till now what you've done is sequential control flow, right? If you write a program, here's the main. It executes this command and then the next command and the next command. You might call a function and you might have a loop, but it's still basically sequential, right? You might have a condition that says do this or do this, but then it goes right back to sequential A, B, C, D, right? Or as command line interfaces. But human-computer interaction, that is modern computers, is done through graphical user interfaces. Those could be thin clients. We generally refer to browsers as thin clients, which are basically means that you're making an SPA, a single page application, or a web application, or something like that in HTML, JavaScript, and CSS in order to get something that looks like this, right? And this can run on any browser. It's a thin client because it doesn't require you to install anything other than the browser, right? Thick clients, however, are full programs that are compiled for a particular system. The browser itself is a thick application. Let's see, what am I running right here? I'm running Atom.io, which is an editor. And that's a thick client application because, well, technically it's an in-between because I think it's Electron, which means that it's a web app, but then they take the browser and compile it all together into one thing to make it look like a thick client application. But you know, things like Microsoft Word or OBS Studio that I'm running right now, those are thick applications, thick client applications. Event-based programming means that you aren't doing that sequential control flow anymore, right? Human interactions are now in the equation. They're handled by a windowing system, right? Where somebody clicks a button or types something on their keyboard. Those are events that trigger whatever handles those events. When I click on that button, what should happen, right? Well, this piece of code over here, that's a handler. How does that entire process work? You have a windowing system that says, oh, hey, there was a button that's clicked. I'll notify that handler over there so that it takes care of it. That's handled by your code. The event itself is handled by the windowing system. So it's kind of different in that actions like input happen outside your program, not inside your program. Your program only specifies what happens in the event that somebody clicks the button. You don't have if they click the button, right, and then you do this. It's not sequential anymore. Instead of specifying what happens in a program, you specify what happens when an event occurs. So you may not even have a thick client app. You might not even have like a main. We will have a main in our demonstrations here. But basically, your application is nothing more than what happens in this event, what happens in that event, etc. Right? Here's a brief, uninteresting history of graphical user interfaces. And I only do this to illustrate that it's actually quite old. It goes back to the 70s. In fact, even in the 50s, they had graphical user interfaces, like with missile systems, where you had rudimentary mice, where you had an oscilloscope and stuff like that. And in fact, the first game, it was a form of Pong or tennis or something like that, was programmed on an oscilloscope in the 50s. An oscilloscope, right? It's not a screen. It's the radar things that look like a radar, and it draws it with a fast-moving light or laser or something like that. Only in 1973 did we come to a modern graphical user interface that tried to emulate a desktop. Right, in a traditional desk in an office, you had an inbox and an outbox. You had the trash can sitting on the floor, etc. And you had things that you were working on, and then you put them aside. Right, that all came out of Xerox, the Alto system. Then Microsoft and Apple stole their ideas, basically, and Apple created the Lisa in 1983 and the Macintosh in '86. The first version of Windows came out in '85. And then it blew up, right? These were the first before that, if you wanted to get on a computer, you had to know how to program on a mainframe. These made things accessible to consumers. Now, they still cost thousands of dollars, and so they were out of reach of most American families, but those costs eventually came down precipitously and quickly so that everybody could afford a computer. I remember my first computer that I had to buy with paper route money in the early, maybe 1990 or so, I don't know. Was a Packard Bell, and it still cost me, in $1990, it cost me $2,000. And so just for inflation there, and you're talking about a $5,000 computer, right? For $5,000 today, you could get one hell of a gaming rig. But then, of course, into the 2010s, you had a shift to mobile devices and mobile-first focus. And so, for example, the old click event, right? There's no longer a click event on your phone anymore, right? How do you click on a phone? You tap, or you hold, or you double tap, right? Two-finger tap and stuff like that. So there are with different input devices come different types of events that you now need to handle. And for example, the cutting edge here, no longer Kinect, but the cutting edge would be VR and AR and XR devices that they have hand gestures now. And with I think that the Oculus Dev Kit allows you to do things like, what would this? Grab? No, pinch or something like that is the event or something. Pinch and then move and stuff like that. And they can track your hands now pretty well with just the camera. And so you have different ways of doing input, and you have different events now. There are lots of different frameworks. The ones that we're going to look at briefly here are GTK. That stands for the GNU, or the GIMP Toolkit. GIMP stands for Graphical Image Manipulation Program. And G stands for GNU is not Linux. So you've got an acronym within an acronym within an acronym, and then you've got a recursive acronym at the end. GNU is not Linux. GNU is not Linux, right? Sorry, not Unix. There we go. So what does GNU stand for? Well, GNU is not Unix. GNU is not Unix. Because GNU, it's a joke, right? It's a recursive acronym. The reason we have GTK is because the windowing frameworks for pure C, like the old ones like Motif, were just terrible. In fact, the person who created the GIMP tool, the GIMP program, that's basically it's a Photoshop clone, so that you can do image manipulation without paying $600 for Photoshop. He started writing a Photoshop clone for GIMP, and he just didn't like. He was using Motif at the time, and he hated it so much. He said, "All right, I'm going to put that on the shelf, and I'm going to build a new windowing system, graphical user interface framework, so that I don't have to go through that again." Right, and so that's where GTK came from. GTK, of course, plus would be a C++ library out of that. Qt, of course, is also another rival library, and XW widgets, etc. if you're looking at C++. If you're looking at Java, AWT, Swing, or the more modern way of doing this is JavaFX. We'll look at a version of Swing. And if you're on iOS, that means that you're doing Swift, right? Or you're doing old school Objective-C, right? Or if you're doing a thin client application like a web app, then you're doing CSS, JavaScript, HTML, right? There are basic components. Most of them you don't have to worry about. The windowing system handles the low-level functionality of hardware detection, like keyboard and mouse interaction. You don't have to detect that I moved the mouse up 50 pixels just now, right? That's handled by the windowing system, which is also handled in some ways by the operating system. The windowing manager, and of course also you don't have to say that each pixel is rendered, this is a black pixel, this is a black pixel, this is a black pixel, this is a white pixel. All that graphics rendering and the bezel on this window, right, that it's nice and curved, right, and it's transparent behind that curve. All that graphic rendering is done by the windowing system, which sits on top of the operating system. On top of that, you have the windowing manager that handles the interaction of applications and widgets. Widgets are basically any graphical user interface component, right? They're generic GUI elements. It controls the flow of an application by registering events so that when somebody clicks a button, right, then the event happens and that happens, right? When I click this button, then the windowing manager is responsible for detecting that and then notifying everybody, hey, this button was clicked. If you're a listener or if you're an event handler, go ahead and do your thing now, right? Pop up a dialog that says hello, right? Okay? An event is an action that is initiated outside your program. You don't write the code that says the button was clicked. You only write the code that says, if the button is clicked, do this. Right? In the event that the button is clicked, do this. The place to start are, of course, widgets. They're generic GUI elements. Buttons, sliders, labels, text boxes, all of these things are just widgets. Right? The window itself is a widget. Each one of these buttons is a widget. Right? The title page up, or the title up here on this window, that's a widget. Right? Menus, windows, pop-ups, prompts, layouts, right? Now here there's not a visible layout, but each one of here there is a kind of a visible layout here, right? There's this division up here, there's this area up here, and then in that area I put these 4 other widgets, right? And I put them left to right, right? And I specified that layout. It could be a grid, it could be a row, or it could be columns, or some combination thereof. So understanding event-based programming, why this is important means that you have to understand modal control, user experience or user-centric, like human-centric design, and asynchronicity, right? So again, the window manager waits for actions or events in this infinite poll loop, right? My computer right here is sitting here in an infinite poll loop saying, nothing's happening, nothing. It sits here and waits. Was the button clicked? No. Was the button clicked? Was the mouse moved? No. Was the mouse moved? No, nothing. So it's an infinite poll loop here. Only when I move the mouse now the mouse was moved a few pixels up and to the right. Now, when I move in on this button, did you see that very, very subtle thing that happened? What? It's changed color slightly to give visual feedback to a user, right? A visual feedback that this is interactable now. Now it's not interactable because you're not hovering on it, right? This is interactable, and here's a modal design, right? I can't immediately select option A, B, and C. Only if I've got this open can I select these options. If I've got this open and I try to say hello, in this case, I didn't program it that way, but here, I did program it this way. Once I've got this hello, can I interact with those things back there? I'm furiously clicking right now, just believe me that I am. Can I? No, because I'm in a different, this is a modal dialogue that comes up and says, here is something important. You need to focus on this. That's why it's all blocked out behind it. You need to focus on this and give me some feedback before continuing with the main program here. Right? So modal design means that you restrict a user's access to basically guide them to the correct usage of your program. Right? If they could just do anything at any time, kind of like chaos. Right? There are multiple ways, for example, in Word of saving a file. You could go Control S, right? That saves a file. You could go up to File Save or File Save As. There's also a button there that has an old school disk, right? And when you click it, it saves, right? There are multiple ways of doing the same thing, meaning that you're making it richer for the user. You're making it user-centric, right? And improving the user experience, because some people are power users and they like quick keys. Some people need a little bit more visual help, and so that they like clicking that button, right? Etc. But the modal behavior is that at any time you want to also restrict the users to do the right thing. For example, suppose that that you click delete, right? That's a potentially dangerous option. What should happen? Are you sure? Yeah, a dialogue pops up, kind of like this, but says, "Are you sure? Yes or no?" Right? No, I'm not sure. I didn't mean to do that. Right? So, with maybe not a cryptic message, but a warning: this cannot be undone. Are you sure you want to do this? Yes. Okay. It took two levels of confirmation in order for them to do that. If it was just delete, okay, it's gone. Right? Then that's not very user-centric. That's not very modal, because you've allowed them to do a dangerous operation without confirmation. In fact, I've seen programs that, especially with database stuff, that you're about to delete the entire database. Are you sure? Yes. This cannot be done. Are you absolutely sure? Understand the consequences of doing this? Yes. All right. Are you really, really sure? Right? You could have you could go as many levels deep as you want, right? And that's modal behavior and a user-centric response kind of design. The last one is asynchronicity. You don't want background behavior to interfere with your user experience. User interfaces should not block a program and freeze up a program. You might have experienced this in badly programmed games, right? Where there might be some lag. A well-designed game, say it's an online game, right? And the person that you're playing against has a bad internet connection. And so you're shooting at them, but then by the time your bullets get there, they're over here, right? You didn't see them run over there. They just magically appeared over there because of lag, right? But your bullets didn't freeze in order when they froze, right? Your bullets kept going. The entire time didn't stop just because they had lag. It continued, right? You don't want the program to grind to a halt. Here's an example of that. So again, I can say hello. I can select these actions. When I do, option 1 is selected, option 2 is selected, another option is selected. I think the first one is option 0, right? There we go. So let's look at what's called a busy delay. Now this is a busy pull loop. When I click this, you see that it froze. In fact, my finger froze in this pattern here. If I try to say hello, I clicked it, trust me, it's not gonna work. If I try to click action, it's not gonna work, right? In fact, I got a warning there that's slow. There, finally, when it was done, busy delay done down here, then all those actions that I had done up to that point, they all come, rushing back, right? And say hello is chosen, and this should be, I think that was the only other action that I did. But that's a busy delay, right? Is that good user experience? No. Does your entire web page freeze when you load up more comments from Reddit or from Facebook, if you're on that, unfortunately, right? Et cetera? No, that doesn't happen. That's a bad user experience. Instead, what you want is asynchronicity, an asynchronous delay. The exact same thing will happen in the background. This is a broken image, sorry. But that should be like a loading image, that spinning clock here. There, finally it's done, right? I'll do that again, but it doesn't prevent me from doing things, right? I can do things asynchronously while that's being done in the background. And so that's what graphical user interface programming is. It has to be asynchronous, because if you're doing a busy action like saving a file that is going to take a few seconds, you don't want the entire Word document to freeze up. You want to continue writing, right? So that you can that you have a good user experience. And that requires asynchronicity, meaning that things don't happen sequentially. It doesn't go A, B, C. While C is happening, you cannot do D, right? You need to do things in not necessarily a sequential manner, right? So that was the demo that I just showed you, right? Again, clicking a widget means that it's not frozen, right? So what do you need to implement a graphical user interface? Well, you need 3 things. You need a way to create widgets. You don't want to, I mean, you can if you really want to get down into the low-level weeds and create your own widget. If you have an idea for a new widget, like I'm not creative enough to think of something that, like, before the first button appeared, somebody had to think of a button. Right? Before the first slider appeared, somebody had to think of the first slider. But you don't have to write code to create those widgets. If you think of a new idea for a new widget that nobody's ever seen before, you're going to have to write that code, right? And then integrate it into the graphical user interface, right? A calendar selector, right? Where it pops up a calendar, and then you can go back a month, you can go forward a year, or something like that, and then select a particular date. That's a widget. And it's become a common widget. Before, many years ago, it wasn't that common, so you didn't have those, so you had to hack it together yourself. You need a way to specify the layout of widgets. Here's the first row, or here's a grid, right? And we're going to put a button here, a button here, a button here, and we're going to put a text box here, etc. Once you've created your layout, now you need a way to register events. What happens when you click that button? What happens when you select that text? Can you make that text read-only or write-only, or readable and writable? It's a read-only text box or something, right? So again, before we get into this demonstration of GTK and Swing, if you are interested in getting into more graphical user interface programming, I would do it in a more modern way. If you are wanting to do Java thick client application, get into Java FX and Java XML, where you can define your layout using a XML code, or even better, Java Scene Builder. Let's take a look at what that looks like. Basically, it's a WYSIWYG where you can drag and drop elements. It looks something like, come on. All right. There, that's what I wanted. So it starts out with an empty window, and then you can drag a pane over here. You can drag a button over here, and then click on that button, and it opens up a dialog box where you can start writing code of what happens when you click that button. This is a better way of doing it than low-level code stuff. You're basically wireframing your application and then making it interactive. App Studio is similar. Right? But if you're going to do an Android application, this is the way to do it, right? And you see that you have the same idea over here. That here's the emulator of the phone, right? And you can drag and drop an image here and then move it around and make it smaller or whatever. It's a visual layout editor, right? So that's the more modern way of doing it. And of course, there's a Hello World example here. And most even GTK has a WYSIWYG builder, I think. I just don't know what it is off the top of my head. Question?
So Apple, you would still use Swift?
Swift, yeah, and you'd have to buy a Mac and develop on that. Good luck. All right. So first of all, let's go ahead and not log in. What am I doing? I need to log in as myself. Ignore what I'm doing for now. Basically, if you really want to know what this Y switch is, I'm enabling port forwarding so that I can run a graphical user interface program on the CSE server and have it render on my desktop, right? Because I don't have the necessary tools to actually build this on my Mac here. So let's go into the Keypad demonstration here and make, right. If you take a look at the make file, really complex way to build it, but that's what it takes because you're bringing in a whole bunch of libraries to do this for GTK. So I've already built it. What is it called? GTK, there we go. So wait a few seconds here because it's being rendered on the server, and then it's all those bits are being sent over the network to produce something that looks like this. Right? It's a keypad. Right? And user access. So, I don't know, 2020. Enter. Access denied. Okay. 2016. Access denied. Right? Oh, I made a mistake. It's a four digit. I know that it's a 4-digit. I'll clear that out. Right? So do you see what's happening here? Lots of events. For example, just simply moving my mouse up 1 pixel, it was not even noticeable there. That's an event on mouse move. When I hover over a button, it changes color. That's another event on enter, right? When I click down, that's another event. Now, this has not been pressed because if I move it out and then lift my finger, right, then that's not an event that is a button press, right? That was a press down, move out, press up. You didn't click that button, right? Press down, up. It didn't type 1, right? I only registered the button click, which means that I press down, release without moving outside the button. I can move within the button, right, and then release it, right? That's all handled by the windowing manager. But there are thousands and thousands and thousands of events going off every second, right? Which ones you choose to actually pay attention to, that's what you actually program. Yeah?
So what happens if you hover your mouse over more than one button?
That's not possible unless you have like overlapping buttons, and you can't do that usually in a layout, right? You only have one window that has focus. If I move my focus over to this other window, now the windowing manager has recognized that that application no longer has focus. This one does. So any button and click events are focused on this window instead of that window. The windowing manager handles all that.
And same with buttons, like your 1 and your 4 button, like you can't highlight over both the 1 and the 4.
Nope. I mean, I could drag and then now I'm on the 4, right? And then I released. I'm still on the 4.
I just mean your mouse size is bigger than the gap.
Your mouse is only 1 pixel. Your actual, like this. Yeah, it's only 1 pixel, right? Even though the cursor is hovering over both of these things, the actual mouse is hovering over 4, right?
That's kind of disappointing.
All right, there's a text box. There's a label, right? There's a window. Right? And if I start trying to mash the keyboard, nope. Modal Design, right? You can't type hello here because you can't type at all. You have to use numbers, right? And so that's Modal Design. I'm restricting what they can do at any one time. I'm restricting the type of input they can give me. On a command line interface, that's not always that easy, right? So what do you think my password is?
42.
Oh, because of Douglas Adams? Nope. Think Spaceballs. Oh, come on, nobody's seen Spaceballs. 1, 2, 3, 4. Access granted. Spaceballs is that's the combination on his luggage, and the combination to the planet to steal their atmosphere. Also, what happens when I click this X up here? Oh, thankfully, it closes. Right? It quits the program. What if that didn't? That's a registered callback. If you didn't do that, then it would not end the program. Right? I had to actually specify that when you click that X up there, it closes out the program. Now, what does the code actually look like? Yeah, go ahead.
What happens if you don't do that?
It stays open.
Forever?
It stays open until you kill it directly. Control C, right? Yep, you have to manually kill the program. We can do it when we look at the Java version here in a second. But there's my password. I'm bringing in the GTK library. Everything is a GTK widget, including the input box, the message, the label, right? I've got a couple of callbacks up here. Don't worry about those just yet. Actually, no, let's take a look at them. Clear input. That is a function that takes a widget and any data that you want to give it. It doesn't use either one of those things in this case because what I'm doing is I'm getting that input box and I'm setting the text to nothing. What do you think? What do you think this is associated with? Let me run it again. The clear button. Right? How did we associate this function, this clear input, with that clear button? Right? Keep that in mind as we go down. Enter password. That's probably associated with enter. Why? Because it gets the text out of the input box, And then it does a string comparison. If that input text is equal to our password up here, 1234, then what we do is we set access granted, otherwise we set access denied. Right? And we make this one green and bold, and this one red and bold. If you're not familiar with this, this is rudimentary CSS, cascading style sheets. Right? Yeah, don't worry about that. And then we clear out the input. Right? We call this other function up here that simply just sets the input to the input text box, right? That I can do this, and then it clears this out. Right? And again, we don't use the widget and we don't use the data, so I'm just passing in null because it does something. Okay? Don't worry about that. Enter digit. What happens is we are given data here. That data is used to associate to 0, 1, 2, 3. It's just a single character basically, or I think a single character string. And what it does is it concatenates. So we take the new input, we establish that to be the current input, and then we concatenate the key to the key that was typed or clicked on to the end of that, so that 1, 2, 3. Then when I click 4, 4 just simply gets concatenated to this string up here. Right? And then we set it. Right? And then I free that temporary input. Okay? Here's where all the main work is actually done. Those are just the callbacks. Those are the callbacks that handle the events. How do I put it all together? I've got the window. Right? That's the window itself. I've got the main column. That's a column within the window where I pack everything into it. I've got the clear button, the enter button, and I've got column 1, 2, and 3. What do you think those are? There's column 1, column 2, and column 3. And then I've got a horizontal box, top, to hold this label here, a horizontal box mid to hold the text box, and then a horizontal text box for the keypad where I'm going to put this 1, 2, 3 columns. So I've got 3 rows, and in that third row, I've got 3 columns within that row. There are lots of ways that you could have done this. Right? This is the way that I chose to do it. Right? You could have had instead 3 columns, or 3 columns and then a row within the column. Yeah, or 1 column and then 4 rows in that column, or a grid or something like that. Right? This is just the way that it made sense to me at the time. Okay. You have to initialize everything. So that's just getting the GTK library up and spinning. Then all of these are undefined. These are just variables. I have to now create my widgets. Remember that you need a way to create widgets, specify a layout for the widgets, and specify a way to register callbacks. Here's that number 1. I create a window using GTK window new. I set its border to have a thick border of 10 that's right here, 10 pixels. That's why otherwise if it were lower, then it would be a little bit crowded. If it were more, then you could have 20 pixels here, and then there would be some extra padding there. I associate the destroy event, that is this event up here, that when you click this X button, with a quit function. Right? If I didn't do this line right here, then this would effectively do nothing. Or it might destroy the window, but it doesn't kill the program. Right? Then I create columns and horizontal boxes. So my main column is a vertical box, a new vertical box. Column 1, 2, and 3 are also vertical boxes. Otherwise, the top, mid, and keypad are all horizontal boxes. The only difference between a vertical box and a horizontal box is when you start adding widgets to that box, does it add top to bottom, or does it add left to right? Then I have to start adding everything. This is my actual layout. So this is the number 2. Once I've created those widgets, I need to specify this layout. I'm going to add to the window the main column. Then to the main column, I'm going to add the top, the mid, and the keyboard. To the keyboard, I'm going to add column 1, 2, and 3. And so I've got this layout now. Right? Lots of code just to specify a layout. Again, if you want to, you can use a WYSIWYG layout editor like this, and then just drag and drop stuff if you want. Right? That's much better if you're going to do this for a long period, extended periods. But I'm showing you this because this is how it actually works at the end of the day. This WYSIWYG layout editor is simply just generating code to do what you just did. Right? I create a new label here, user access. Remember when we started this up, that was the default display, user access. Right? And then I put that into the top box. Right? Then I create that input entry. That's a text input box entry. Initially, it'll be empty, and then I make it editable. No, false. You can't edit it. So that prevents some mashing the keyboard. Right? I show that every widget needs to be shown. By default, it's invisible. That's so that you can hide things in the background and then make them visible later on if you want modal interaction. Right? HBox mid. The same thing happened over here on this web page. Say hello. This box here is actually in the background somewhere, invisible. Only clicking this makes it visible. Clicking OK makes it invisible again. Right? That's how these things work, right? It doesn't actually create a new. I mean, you could write code to create a brand new box and launch it if you want to, but that's not how I chose to do these. Then we've got all the keys. 7, 8, 9. Why 7, 8, 9? I'm adding them. First one, first one, first one. Column 1, column 2, column 3. And you can see me doing that down here. Oh, no, here. 7, column 1, column 2, column 3. And there are a whole bunch of options here. Don't worry about it. Column 1, column 2, column 3, 4, 4, 5, and 6. 1, 2, and 3. And then the clear button, I should have put clear up here, but that's column 1, then column 2, then column 3 for the enter button. Right? 200 lines of code just to specify, 170 lines of code, 150 lines of code just to specify a layout of a keypad. That's it. Right? Now you register callbacks. When the clear button is clicked, call this function over here. Remember clear input? What did it do? It cleared the input. When the enter button is clicked, call that function right there. Right? When the 0 button is clicked, call that enter digit function and then pass in 0 because we clicked 0. Otherwise, pass in 1, 2, 3, 4, 5, 6, 7, 8, 9 for all the other keys. Right? Show all those windows. Finally, show the window and kick it all off. Right? This GTK main just means launch the application. And now it's in an infinite pull loop until I do something. Right? And I'm doing a lot here. Even though I'm not clicking anything, every time I move the mouse, that's an event. Right? Anytime I mash the keyboard, that's an event that ends up getting ignored. Why? Because I didn't register a callback. Right? Pressing the escape button does nothing because I didn't specify that anything happened when you press the escape button. I would have to specify a key down, and then, okay, what key was it? Oh, it was the R button. And then that launches a rainbow or something. I don't know, whatever. Yeah?
Where's the code that makes it so that the button changes color whenever
That's handled by the windowing manager, right? All that graphical rendering is handled by the windowing manager, or the windowing system itself. Now, if you wanted to, that's the default behavior. Of course, if you wanted to make it so that when you click it, it becomes blue, right? Then you would have to specify that. You'd have to register a button down instead of clicked. On button down, change the color of your button to blue, right? And there are functions to do that. Right? Otherwise, I just did all the defaults up here. Right? Say what? Okay. So that's the keypad with respect to GTK. Let me go ahead and kill it. How does it look like? What does it look like in Java? This is included with Lab 14, by the way. This is just code from Lab 14. A J-frame. Well, a frame, a window, right? Same idea. I've got a text field that's an input, right? J text field. These are all widgets, and this is how you create widgets. And I've got my password here. I've got a label widget, a J label, right? And by default, it has user access here. In fact, let me launch this. Wait. It looks different, but that's because the windowing system is different, right? I think I made it, nope, this is read only, but I've got, 1111, clear, 1111, enter password, denied, right? Same exact thing here, 1, 2, 3, 4, enter, granted, right? So same exact ideas. You have to initialize the GUI, that's in the constructor here. What do? I set the input box to editable false so that you can't mash the keyboard, right, with bad input, Modal Design. Then I have to create a panel. I add the label, I add the input. By the way, it's all horizontal glue, right? Just like an H box in GTK, a V box in GTK. I say create horizontal glue or vertical glue, right? I chose here to do a grid layout. 4 rows and 3 columns, right? 4 rows, 3 columns. For the keypad, that is, right? That's the grid layout for the keypad. I set an H gap of 10, that's, again, I could make this 100, right? And you can see the differences here. Let me go ahead and kill this and launch it again, and it looks terrible, probably. Yep. Why does it look terrible? Because I put 100 pixels between each one, right? So let's be a little bit more judicious here, right? You don't want all your buttons mashed together, but you don't want them all far apart, right? This is all the art of graphical user interface layout. And of course, if you were doing something WYSIWYG, like scene builder or app builder or something like that, then you can move it just slightly. Okay, that's perfect, right? Yeah. Oh, you don't? 10 seemed good to me. Do you want 15 instead? Or 0, right? And then everything is clumped together all at once. But yeah.
Can we use WYSIWYG design in our labs?
If you want to get into app, but JavaFX builder, that's fine. Yeah, I don't think you're going to want to do that though. We give you a half-completed program already. That would require you writing it from scratch. But anyway, there's keypad 7, 8. Oops, did I call it 8? Yeah, 7. There's 7. There's 8, 9, 4, 5, 6, 1, 2, 3. Clear, 0, and then and then the enter button. Let's just look at one of them. All right, well, actually, let's look at one of the keys. Here is me creating that 2 button. Let's launch it again so that we can actually look at it. Here's the 2 button. When I click it, it obviously puts 2 up here. Right? How does that work? Well, 2 is the label that I put on the button so that you know that it corresponds to 2. If I wanted to, you could go something like this instead. And you see the difference. 2. I wouldn't do that though. And then what I do to register a callback is I set what's called an action listener. Now this listens for actions. Are you clicked? Are you clicked? Are you clicked? No. Basically, it all depends on what type of widget it is. Some widgets don't have a clicked event, like I don't know, maybe the J level here, the label widget does not have a clicked event. But these buttons certainly do. When it gets clicked, then this code is executed. And all we're doing is taking that input box, setting the input to the old input concatenated with 2. Okay? Just like we do up here. 2, 2, 2, 2, 2. All right? Clear that. What does clear look like? Well, we just simply set it equal to, or not that one. Clear is right here. We simply set it equal to the empty string. What does enter look like? Well, we do, is the password equal to the text? If so, we set it equal to granted. Otherwise, we set it equal to denied. And that's it. We're not actually clearing the input here. We could do that. Oops. Undo. There we go. So we can add input.set text to try again. Let's see what this looks like. Now this, of course, is not going to work because if we get it wrong, 1, enter, try again, and it'll just start concatenating to that. So we probably don't want to do it that way. Clear it, there we go. But we can go ahead and set it equal to the empty string. Okay. We set the title of the entire thing to Keypad, and we make it initially 250 pixels by 250 pixels. This does not actually get started. Only if you have a main does it get started. Swing utilities, we invoke this as a runnable. Why? Because it runs in its own thread. Why? Because of asynchronicity. If it ran on the main thread, then you would have busy delays like this, preventing you from doing anything. Okay? All right. Those are the basic ideas. And unfortunately, I can't, there we go. Now I don't get too hyped up about doing graphical stuff because I'm not a graphical user interface designer. I know what looks good. That looks good, but I didn't write it. I can't. I just used a framework to do it for me. In this case, this is a Bootstrap framework. All right. Questions? Otherwise, again, all you need to do graphical user interface programming is learn a library. Unfortunately, it's very, very specific. Once you learn the basics, these three things, then you can go to, okay, I want to do an Android app. How do I create widgets? Well, okay, there's how I create widgets. How do I specify the layout? I can use the builder. How do I register events? Right? And that's all there is to it. Every framework will have these three basic steps. Unfortunately, when you learn one framework, you're locked into that framework. You can't take, say, a swing application like this Keypad demonstration and transport it over to GTK, right? You have to write it from scratch. Right? Now, there are attempts at cross-platform kind of stuff. Like, for example, you can write a graphical user interface in Python. I forget what the framework is, and then it will compile into you can then hit, compile it to an Android app, and it will produce an Android app code. Compile it into iOS app, and it'll produce an iOS version of it. It's not always 100% successful. It won't exactly look like what's called a native app, right? When I launched this, right, those buttons look like Mac OS, right? That's because that is the Mac OS, or does it look? Nope. Yeah, it looks like Mac OS. It doesn't always look that way though. It would look a lot better if I had done this in like Swift, and then it would look like it actually belongs to this operating system. It doesn't look exactly like it belongs here in the Mac world. If I ran this, it'd probably look a little bit different on your Windows machine, for example. It would look more like Windows, but not exact, because I haven't used Microsoft's WinForms or whatever the hell they call it nowadays. Right. Question?
So we only need to do one of these labs?
Yeah, one of those. If you're going to do either of the C versions, you're going to have to do it on the command line, CSE, because CS50 does. I tried desperately to install everything for the database lab. I could not get it to work. You're going to have to go to the CSE command line. For this, you're going to have to probably use port forwarding or go into the actual lab to do it. The grader, of course, can't run this, right? The grader is just simply going to compile your code to make sure that it actually compiles, and then we'll take a look at it. I will take a look at it. But otherwise, if you do either of the Java versions, you can just do both of those in Eclipse. You just need one of those four. And so I would suggest, going with the Java versions. All you have to do, by the way, for these is, here's the actual lab here. You're given a calculator. What does it look like? Once it finally, here's a simple calculator. 12, 45, add them together, subtract them, multiply them. Is that right? Yeah, multiply. Add a division, right? So it looks, you can get as fancy as you want. And so if I divide by 0, what should happen? An error message, maybe, I don't know. But you can also quit. All right. So any questions about that? Otherwise, again, I don't like to get into it too much because I can't, I'm not a designer. In fact, usually there is a separation of responsibility. People, like designers, will wireframe stuff and say, it should look like this, right? But they won't make it functional at all. They'll just make it look nice. And then they hand it off to a real programmer that says, okay, I can type that up. I can make that button appear right there. And yeah, I'll tweak, okay, it should be RGB value of 47, blah, 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 right? Whatever you made in your wireframing stuff, I'll make it, you made it look pretty, I'll actually implement it so that it's functional. In fact, they can even, wireframe it using something like this, like the scene builder, and then hand it off. Okay, now when that button clicks, this should happen. I don't know how to do that because I don't know how to code. That's what I would take over. Because I'm not all that interested in, making stuff look pretty. Anytime I've ever tried making it look like a graphical user interface pretty, I'm always just like, okay, it needs to be over one more pixel. I get way too bogged down in the details. That's why I like frameworks like Bootstrap, where that's a nice blue. I don't know, that's a cornflower blue. I don't know what it is. But they decided that was a good color and good color combinations. All right, Bootstrap Alpha, okay. Examples? There. That looks like a nice layout there. I'm just gonna use that. Oh yeah, nice menu up there. Right. That's what I'm gonna use. All right. Then we will review on Thursday. Any questions online? I didn't see any. Nope. All right. Have a good Wednesday. Make sure that you are continuing on your assignment 6.